This is the last tutorial for the Chapter 1 performance task. The similar problem to number 4 that you'll see, and it talks about how Jen assembled fuel pumps and she earns extra pay for completing 3/10 of the fuel pumps prior to the expected assembly time. She needs to assemble 310 fuel pumps today, and after building 35, so that's an important number, so she has to build a total of 310. But she's already built 35, and 20 were assembled before the expected time. And so we're supposed to write an equation to solve an equation to determine how many more fuel pumps. So how many more fuel pumps Jen must assemble prior to the expected time. So this is the question there, and so we're going to call that our unknown. So x equals the number needed to assemble. So she only has to assemble 3/10 of the fuel pumps prior to the expected time. So let's do this. Let's find out how many she needs. So 3/10 of 310 is what they're asking for. And so this is going to give us the amount needed to be able to assemble prior to that expected time. And so if I do that, I'll go ahead and multiply these numbers. And when I see a fraction, I'm going to write the 310 as a fraction, I see that 10 can be divided into this 310 as well. So it's going to leave us with 31. So I go ahead and multiply across. It leaves me with 93 fuel pumps needed to be assembled prior to the expected time. So 93 fuel pumps needed to be assembled prior, so that means before the expected time. Alright, so from this point we want to find out how many more she needs. Well, let's do this. Let's take that 93 and let's set it equal to how many she's already done, 20. She's already completed 20 prior to the expected time. And so we also have to add on how many more she's going to need. So x is going to be how many more she needs. And so from this point, all we have to do is solve. So I'll subtract the 20 from both sides. And so it's going to leave me with x equals, and I can do this work here, and I end up with 73. So x equals 73 more fuel pumps that need to be assembled prior to the expected time. Alright, that's going to be our answer there. And our equations up top. We also have to do some side work here as well. And let's take a look at the next one. It says that what fraction of fuel pumps has Jen assembled prior to the expected time? Well, what fraction has she done? Well, that initially she's only completed 35 and she's assembled 20. So it would be 20 over 35. So 20 assembled prior to expected time, and 35 was the total number, or total assembled. So what we want to do is just reduce this. So let's take out a common factor here. I see that we can divide each of these numbers by 5. And so when I do that, what I'm left with is 20 divided by 5 gives me 4, and 35 divided by 5 gives me 7. So let's read on what they want next. So what fraction must she finish from now on to get the extra pay? Well, we know from the problem above that she needs 93. Well, she's already assembled 20, so let's subtract those two numbers. And we know that the total number is 310 that she needs to assemble that day, and she's already assembled 35, so we'll subtract those two numbers. And when we go ahead and do the subtraction, I'm left with 73 over 275. And so what they ask next is it likely? Well, likely means like over 50%. Over 50%. So over 1/2. Is it likely she will get the extra pay? Explain your reasoning. So what I would end up doing is I would go ahead and check to see what the decimal form of this is, and then just change it to a percent to better understand the number. So 7 doesn't go into 4, but it does go into 40 5 times. And it leaves me with 5 left over. So I'll bring down the 0, and I get a 7 here. And I'm just going to go one more time here. I got 1 left over, so bring down the 0, and I go 1 time. So it's going to be about 57%. Move the decimal 2 spaces over, and that changes it to a percent. We're over here, this number was, let's see, this number is 73. And so I'm going to do that same process with this one, 275. Oops, 275. And do some division to find out how many times it goes into 73. Well, it definitely doesn't go into 73, but it does go into 730. So if I cover up these, the 5, and I see how many times 27 goes into 73, it would go 2 times. And doing that math, I get 10, 14, and 1 makes 15, and that would give me 5. And so I go ahead and do the subtraction, and that leaves me with 180, which is smaller, so I'm doing fine so far. Now I have to do 275 into 1,800, and I'll try 6 times, and that gives me 30, and 42 and 3 gives me 45. 12 and 4 give me 16, so that looks like it's going to work out as well. Got to borrow a little bit there, so that changes to a 1. And I'll go ahead and just go one more time here, and I see that it goes in here, probably close to 5 times. So that's going to move that decimal over 2 spaces, so it's going to be somewhere near 26 to 27%. So what I see is that so far we're completing 57% of them before the expected time, and all I would need to do to get to make it so I get my extra pay is just to do 26%. So I would say yes, it is likely Jen will receive the extra pay because she is currently assembling the fuel pumps at a rate of 4 to 7 prior to the expected time, which is over 50%. So you see how if I did 4 into 7, or 7 into 4, that gives me 57%. So that's higher than 50%. So definitely I would say it's above that, meaning that it would be likely. And so yes, I do think she'll end up getting that extra pay, as long as she keeps up with what she's got. So those are the types of problems you're going to end up seeing on that performance task. Good luck.